In a triangle ABC, a straight line parallel to the side BC divides the triangle into two parts of equal areas and meets sides AB and AC at D and E respectively. Which of the following is closest to the ratio AD is to DB in which the straight line divides the side AB? And we are given four, or rather five options, out of which we have to pick the correct answer. So this is a question where the correct answer is kind of counterintuitive, and I'll explain that as I solve this problem why that's the case. So let's start with the triangle ABC, and a line parallel to the side BC divides the triangle into two parts of equal areas, and it meets the sides AB and AC at D and E respectively. Now, just by the fact that it divides the triangle into two parts of equal areas doesn't necessarily imply that it also divides the sides into equal proportions, meaning that it doesn't divide the sides equally, like the median of a triangle, for example. So we know the median of a triangle divides the triangle into two parts of equal areas, right? But the median, by definition, it also divides the side into two equal parts because it joins the vertex of the triangle to the midpoint, the middle point of the side opposite to the vertex. But in this case, the line that divides the triangle, that's parallel to the side of the triangle. So it's not the median, and this is where some may be mistaken and may actually go for option A. Just because it divides the triangle into two parts of equal areas doesn't necessarily mean that it also divides the two sides into equal parts. So that will become clear as we further solve the problem why that's the case. But for one reason to mention right now would be that if you look at the two parts in which the line parallel to the base divides the triangle, the original triangle, so one of those parts is a triangle, the other is actually a quadrilateral. So we have the triangle ADE, the smaller triangle on top, and we have a quadrilateral BCED that's at the bottom. So how do we solve this problem? So first of all, we consider the fact that the line DE is parallel to the line BC. So angle ABC would be equal to angle ADE. So those are the angles that are marked in green. And similarly, angle ACB will be equal to angle AED. So those are the angles that are marked in orange. And this makes the smaller triangle ADE similar to the bigger triangle ABC. And we know from the property of similar triangles that the ratio of corresponding sides as well as the altitudes of the triangles should be equal. So if we draw the altitude or the heights of the two triangles, so the smaller triangle, the height is represented by lowercase h, and for the bigger triangle the height is represented by uppercase h. So the ratio of the corresponding sides of triangles ADE and triangle ABC, so that's AD by AB equal to DE by BC, and also the ratio of the heights of the two triangles, they should all be equal. And let this ratio be R. So what's the area of triangle ADE? The area of triangle ADE is basically half into its base DE multiplied by the height of the triangle H. And this is lowercase h, right? Now, we can express DE in terms of BC from the expression that we wrote, for the fact that the corresponding sides should be proportional. So DE by BC is equal to R, which makes DE equal to R times BC. So that's the substitution we have made. So DE is equal to R times BC. And similarly, the height of the triangle, the smaller triangle, that's the lowercase h, would be R times uppercase H, which is the height of the bigger triangle. So those are the two substitutions we make, and we get half DE multiplied by lowercase h will be equal to half multiplied by R times BC multiplied by R times uppercase H, which is the height of the bigger triangle. Now, we can rearrange this as half multiplied by R square multiplied by BC multiplied by uppercase H. So what is BC multiplied by H? Well, if you consider triangle ABC, its area will be basically half multiplied by its base BC multiplied by its height uppercase H. So BC multiplied by uppercase H will be equal to 2 times the area of the triangle ABC. So we can replace BC multiplied by H as 2 times the area of triangle ABC. And here half and 2 gets cancelled out, and we are left with R square multiplied by area of triangle ABC. Now, what is triangle AED according to the problem? The area of triangle AED according to the problem should be half of that of the bigger triangle, because the line segment DE divides the triangle ABC into 2 parts of equal areas. So the smaller triangle ADE must be equal to half the area of triangle ABC. But from all the work we done in expressing triangle ADE in terms of R and area of triangle ABC, we have basically gotten the equation that area of triangle ADE is equal to R square times area of triangle ABC. So we just replace or substitute that on the left hand side of this, and we get R square multiplied by area of triangle ABC is equal to half area of triangle ABC. From here, we get R square is equal to half, because the area of triangle ABC gets cancelled out from both sides, and from that we get R is equal to 1 over root 2. Now, what is R? R is essentially the ratio of the corresponding sides of the two similar triangles. So AD by AB is equal to R, and that's equal to 1 by root 2. So note that the ratios here are all given in terms of integers, right? And we have to really pick the ratio that's closest to the actual value of the ratio of AD by AB, or rather AD by DB. So what we do at this stage is we replace 1 by root 2 so by its integer approximation. Essentially, estimating root 2 as 1.4, so that's a very well-known approximation of root 2, and then we convert this into integers, the ratio of integers. So if you multiply both the numerator and the denominator by 10, we get 10 by 14, and then we can further reduce it to 5 by 7. Now this is AD by AB, but the problem doesn't ask for AD by AB, it asks for AD by DB. And that's actually pretty simple. So AD by DB, so what's DB? DB is basically AB minus AD. So we have AD by DB is equal to AD divided by AB minus AD. And then if we divide both the numerator and the denominator by AD, we are left with 1 divided by 1 minus AD by AB. And AD by AB, we have approximated that in terms of ratios of integers as 5 by 7. So we substitute that here. So we are left with 1 divided by 1 minus 5 by 7. And that comes to 7 by 2. So the correct choice for this particular question will be the option E, which is 7:2.